Without using a calculator and using only your knowledge of the unit circle and the trigonometric identities, determine the exact value of arc tangent of 1 plus arc tangent of 2 plus, you guessed it, arc tangent of 3. Now before we do this, let's briefly go over what the arctangent function is. Well, the arctangent function is a function whose domain is all real numbers. So the input to this function, we can input any real number, and it outputs a number that's in between negative pi over 2 and pi over 2, but not including negative pi over 2 and pi over 2. Moreover, arctangent acts like an inverse to the tangent function, but only for a particular chunk of the tangent function. So what I mean by that is this, is if I were to take the arctangent of the tangent of x, then this is equal to x if x is in the interval from negative pi over 2 to pi over 2. And also, check this out, if I were to take the tangent of the arctangent of, say, some number a, then this is equal to a for any a in the real numbers. So one way to think of the arctangent function is if I have the arctangent of, say, some number b, some real number b, then this is equal to the angle theta in between negative pi over 2 and pi over 2, such that if I were to take the tangent of that angle theta, remember, if I'm taking the tangent of theta, then I'm taking the tangent of arctangent of b. So if I take the tangent of that angle theta, then I'm just going to get b. So check this out. We know something about the arctangent of 1. We know that if I were to take the tangent of the arctangent of 1, then this is just equal to 1. It's just equal to 1. So we know that arctangent of 1 is some angle. I'm going to call this angle alpha. Such that when I take, oh, by the way, remember, it's an angle alpha in what? Where does that angle alpha live? Well, it lives in between negative pi over 2 and pi over 2. Or another way to think of this is it lives in the right half of the unit circle. It lives in the right half of the unit circle. So when I take the tangent of this angle alpha, and when I take the tangent of an angle, it's the same as taking the sine of that angle over the cosine of that angle, then I'm going to get out 1. It's going to spit out 1. So the question is, if you want to determine the value of arctangent of 1, which is a nice starting point to determining the exact value of this guy, arctangent of 1 plus arctangent of 2 plus arctangent of 3, then I want to figure out what angle alpha in between negative pi over 2 and pi over 2, is it true such that when I take the sine of alpha over the cosine of alpha, I get 1? Or in other words, if I were to multiply both sides of this equation right here by cosine of alpha, then I want to figure out what angle alpha in between negative pi over 2 and pi over 2 satisfies the property that sine of alpha is equal to cosine of alpha. Pause the video and see if you can determine what angle alpha between negative pi over 2 and pi over 2 satisfies this property right here. So I'm assuming you've had a go at it. Check this out. If I were to walk around the unit circle, pi over 4 radians, then that point at which I stop has xy coordinates square root of 2 over 2, comma comma square root of 2 over 2. This means the sine of pi over 4 is the y-coordinate of this point, and the cosine of pi over 4 is the x-coordinate of this point. So check this out. Check this out. Alpha has to equal pi over 4 because pi over 4 is indeed in between negative pi over 2 and pi over 2. And sine of alpha, sine of pi over 4 is equal to square root of 2 over 2, or square root of 2 over 2, the y-coordinate of this point. And cosine of pi over 4 is the x-coordinate of this point, which is square root of 2 over 2. So this means that alpha, which we set equal to the arctangent of 1, is equal to pi over 4. So we have just accomplished our first step in determining what the exact value of this sum is. Check out the second part of this video to determine how we're going to determine what this value is, what the value of arctangent of 2 plus the arctangent of 3 is.